When you think about it, our entire modern world runs on these invisible forces. And there's this one single engine, this one piece of tech that powers almost everything we do, from the food on our plates to the phone in our hands.
So let me ask you this. What could your smartphone, a piece of fresh fish for dinner, and a cool movie theater on a hot day possibly have in common? It sounds like the setup for a weird joke, right? But the answer, well, it's something that literally built the world around us.
All right, let's jump in and solve this thing. It's time to pull back the curtain on this hidden engine.
Yep, it's refrigeration. And look, I'm not just talking about the fridge in your kitchen. We're talking about a massive, world-changing industrial process. It's the secret sauce behind making pharmaceuticals, building microchips, and yeah, enjoying a cold drink. It is without a doubt the unsung hero of our time.
Okay, so how does this whole thing actually work? The first thing you've got to get your head around is that refrigeration doesn't create cold. No, that's not what's happening. It's actually all about moving heat. It's not magic, it's just some really, really clever physics.
At the heart of pretty much every fridge and air conditioner is something called the vapor compression cycle. Now, that sounds complicated, but I want you to picture something simple. A heat sponge. That's all it is. A sponge that's constantly soaking up heat from one place and then squeezing it all out somewhere else.
Okay, let's walk through this. Step 1, evaporation. Inside the cold part, a special liquid, the refrigerant, turns into a gas. As it does that, it soaks up heat. That's our sponge getting wet. Step 2, compression. A compressor then grabs that gas and squeezes it hard. This makes it super hot and high pressure. Step 3, condensation. This hot gas now flows to the coils on the outside, and this is where we wring out the sponge. It releases all that heat into the air around it and turns back into a liquid. And finally, step 4, expansion. That liquid shoots through a tiny valve, the pressure drops instantly, it gets incredibly cold, and boom, it's ready to go back inside and soak up more heat. It's this beautiful, continuous loop.
So that simple little loop, it did more than just give us cold drinks. It completely, utterly reshaped human civilization. Let's really dig into how this one process literally built the world we live in.
And what's so wild is where it all started. Air conditioning wasn't invented for us to be comfortable in our homes, not at all. Its first jobs were industrial. Eastman Kodak needed it to keep film from ruining. Printing presses needed it to control humidity so the ink would set right. It was a tool for precision long before it was about comfort. Although, the casino in Monte Carlo shows that the wealthy definitely caught on pretty quick.
But maybe the biggest, most life-altering change happened with our food. I mean, just think about it. Before refrigeration, you ate what was local and you ate what was in season. Period. That was it.
Refrigeration gave us the cold chain. Picture an unbroken chain of cold, all the way from the farm or the fishing boat, to the truck, to the warehouse, to the grocery store, and finally to your fridge. By slowing down spoilage, we could suddenly ship fish, meat, and strawberries across entire continents. It meant you could eat fresh produce year-round, and it totally transformed our diets and the global economy.
Okay, so it changed our food forever. But the story doesn't stop there, not even close. That same idea, controlling temperature with precision, became the absolute foundation of our entire high-tech world.
Just look at the range of things that depend on it. You want to make a microprocessor for a computer? You need a super clean, humidity-controlled room. How do you do that? Refrigeration. You need to machine metal parts to tiny tolerances without them warping from heat? Refrigeration. Making sterile medicines or even weaving stronger yarn for our clothes? You guessed it. It is the invisible engine behind almost every modern industry you can think of.
Now, all this incredible tech, it isn't just a bunch of clever engineering. It's all built on and has to obey some of the most fundamental, unbreakable laws in the entire universe.
And that rulebook is called thermodynamics. Don't let the name scare you. It's just the science of energy, the rules for how heat and work can get things done. And a refrigerator? It's basically a perfect real-world masterclass in thermodynamics.
One of the biggest rules in that book has to do with something called entropy, which is really just a fancy word for disorder or messiness. And the second law of thermodynamics basically says you can't get rid of disorder in the universe. You can't just destroy heat. You can only move it around. And that's exactly what your fridge is doing. It's taking the heat, the disorder, from inside the box and pumping it out into your kitchen, making the universe as a whole just a tiny bit more chaotic.
So when you add it all up, the science, the way we eat, the very things we build, you start to realize something pretty profound. We don't just use refrigeration, we are literally living inside a world that was built by it.
I mean, just look at this contrast. We went from a world that was small, local, and seasonal, where comfort was a luxury and you just couldn't build huge cities in hot places. And now? Now we have global food, high-tech everything, comfort on demand, and massive, sprawling cities in the middle of the desert, like Phoenix or Dubai. This technology didn't just make our lives better. It completely redrew the map of what was humanly possible. At the end of the day, we've built ourselves an air-conditioned planet. But this incredible, unseen engine, it's hungry. It uses a ton of energy, and as the world keeps developing, and frankly, as it gets hotter, our reliance on it is only going to grow. So that leaves us with a huge question, maybe one of the biggest challenges we face. We built our modern world on the power of cold. How are we going to power it sustainably into the future?